Hello, my name is Bernard Alaka from Strathmore University. I'm happy to present to you this concept on a real-time location-based prototype for notification of crime hotspots using crowdsourcing. This is a research we did together with Dr. Bernard Shibwabo and Marilyn Chepngetich. We draw our motivation from the fact that security has always been an issue in most governments, and we particularly zeroed in on the government of Kenya and the rest of security that have become more rampant, especially given the fact that criminals now turn to the use of modern technologies to perpetrate their causes of action. And therefore we saw this as a justification for coming up with a way of tracking these criminal activities, not just within a constrained location, but then within a wider metropolitan area. So this we saw would be made possible using crowdsourcing, which is defined as a form of outsourcing that does a sort of an open call to the public and seeks for information regarding different kinds of phenomena. So mostly this kind of information is sourced from social media or many other internet forums. And so we saw that crowdsourcing could be a very much important tool to use when trying to report crime hotspots. In as much as crowdsourcing is a very much cool tool to use, not all citizens take part in internet forums, and so we are leveraging on crowdsourcing that has made many advancements in technology across the world, but then at the back of our minds we are very much aware that not all citizens take part in this process, and so there was yet another need to take keen note of involvement of the citizens. The aim of this research was therefore to develop a model for real-time location-based prototype for notification of crime hotspots using crowdsourcing that I have just explained. Data gathered for this platform is to be sourced from different criminal activities as presented by citizens on various internet platforms. The solution, therefore, is a concise and effective tool that will guide in crime prevention. So in order to achieve this main objective, the following specific objectives were set. We first investigated factors that were relating to crime hotspots identification, and then we reviewed existing technologies and solutions that are used in identification of crime hotspot areas. We then developed a cloud-based prototype for gathering criminal-related information that will be used to analyze in order to identify crime hotspots areas in Nairobi. We then validated our proposed solution. The development methodology that was used was agile development methodology, and this was specifically due to the fact that it allows for a stepwise kind of prototype testing. That is to say that each step allows you to test how far you've gone with the prototype. And so the first step is the requirements gathering stage, which involves us collecting the product specification. You'll see the response of the research pertaining that. The second step was the architecture and design stage, where we designed the architecture and design, and also the design of the system. The third stage was where we developed the system and implemented it, and finally we tested and we sought feedback relating to the system that we developed. So as to get feedback and also to know the user involvement as far as crowdsourcing, particularly over Twitter platform, will be how far they'll be involved. we sought to use sampling formula that is displayed on this slide, and using this formula, the sample size zeroed in or reduced to about 100 participants, and this was out of a population of 50,000. Following that research, 82% of the questionnaires we sent out were returned successfully and 18% were not returned. Out of the 82%, 48 were male respondents and 26 were female respondents. So one of the questions we were very much interested to know pertaining this research was how much the participants were exposed to crowdsourcing platforms, and we ranged our scale between very exposed to unexposed, where very exposed was given as a weight of 5 and unexposed was given a weight of 1. So the results show that about 33% or a little over 33% were very exposed to crowdsourcing platforms, for instance Twitter, and just about 6 to approximately 7% were unexposed. And this gave us some hope as researchers that us leveraging on crowdsourcing platforms was really a good decision to make, that a number of people would therefore provide us with information regarding crime hotspots. The other question was willingness to support crime sourcing platform. The pie chart there shows the proportionality of how many were willing, how much were willing and unsure. A bigger portion of the sample we interviewed were willing to support crime sourcing platform. So then this is the architectural design of the system we had. It is divided into 3 or rather 4 modules. That is the web portal view, that is a simple web application, a crowdsourcing server, an external database that basically interfaces with external services, that is Twitter, Facebook, Telegram, and WhatsApp. But then for the simplicity of this research, we zeroed in on Twitter platform alone. And so within the web portal view, you have the application itself performing function calls to a local data store that is also interfacing with the Twitter external service, and draws data pertaining criminal reports or crime activity that has been reported by local citizens over Twitter. Then some data mining is done and an authentication on the location of that data is made to verify really if the person who tweeted is from within the locality that they claim to be. Alongside that, a keyword search is performed to specify the gravity of the matter, if it is something that needs urgent attention or if it is something that needs investigation. So this is just for the sake of richness of the kind of reports that we offer in our dashboard. And so this is the first screen you see when you log into the system, a basic login that requires a staff ID and a password. And once you're logged in, you are welcomed to this dashboard that gives you a nice summary of the activities that have been mined from the crowdsourcing platforms, well classified into carjacking, terrorism, theft and banditry, drug abuse, and illegal gambling. This drills down into finer details such as the location, the numbers, and even the messages themselves. Other core modules that we've not shown here is a user module for reporting, for actually reporting the crime incidents, a crime information module, that is used to analyze the crimes as they are reported, that is in real time, and a general information module that is consistently updated as users continue to update the system. This is basically a portal that contains information that is general per the crime updates. And so after showing this to the sample size that we sent our questionnaires to, a bigger percentage, about 70%, approved that the system would actually solve the presented challenges, and 30% were not very welcoming with the idea. So this research has proved that indeed the proposed solution can be used to successfully report crime hotspots and give quite synthesized reports on the same. With relation to user acceptance, a few respondents were a little bit not comfortable with using the platform for fear of being victimized, and this puts forward a need for formulating a strategy that can encourage users to actually use the proposed solution without fear of victimization. One of the weaknesses is that we are only pulling our data from Twitter, but then we seek to use other platforms such as Facebook, Instagram, and many others. And so we intend to find a way of encouraging users to report on these other platforms. Additionally, the other weakness that we realize is that there is quite a debate on whether there should be a login interface, especially for reasons of anonymity and ease of use of the system. So that has been it from me. If you have any questions, my email is blak@strathmore.edu. I'd be glad to respond to your questions. Thank you.